Welcome to the solar thermal technology for industries in Portugal. Case study, cheese manufacturing and milk producing industry. In this presentation is within Sustainable Energy Systems PhD course, Renewable Energy and Resources by Professor PhD Engenheiro António Sarmento, and the author final project was Francisco Costa, the student inside the PhD course. Description of the problem. Facts. In global markets with increasing costs, competitiveness and information, Portuguese industry needs to lower the energy bill while maintaining quality. The problem. Embrace innovation. And the objectives. Use case studies to implement retrofits into more economical and environmental feasible solutions. Using state-of-the-art versus where industry stands will allow to choose the optimal solutions. Here are some photos taken in the field where data was gathered. The methodology was about choosing two case study analyses, technology benchmark, net value costs, economical feasibility, greenhouse gas emissions for environmental feasibility, simulation by manufacturer versus Sultan for sizing validation. Conclusions. So basically we had to assess the industry in Portugal, mainly the industry that has meaning in terms of micro and medium companies. Especially we chose industries linked to rural areas. Milk producing industry and cheese producing industry were chosen, and for milk producing industry representation was chosen Herdade das Pedras no Redondo, which uses electricity by Joule effect water heating to satisfy their daily hot water consumption needs of 5,000 liters per day at 60 degrees centigrade. Applications include milk tanks, floor, animal stable, daily cleaning. This will account for 92.33 megawatt hours per year, and the hydraulic scheme is the one in the slide. Already can be seen that the Joule effect resistances in the tanks will serial contribute, and working in serial they can heat the water to the desired temperature. The retrofit solution aims to add panels, solar thermal panels, that account for 65% of total energy needs, and will use the previous source of energy, which was electricity only for backup energy source. So you can see that the system is working now on more renewables approach. Regarding the other case study for cheese producing industry was represented by case study Queijaria Shoppers. Currently they use propane gas, liquefied petroleum gas for water heating with the same consumption. This consumption pattern basically is not surprisingly equal, because one would expect, since as I saw in the field, their applications, although are slightly different industries, the applications of hot water are basically for sanitation purposes, and this justifies the fact that the consumption are very similar. Again, the difference is that they are using a propane gas boiler. The retrofit system would be also to add solar panels, which would account for 65% of total energy needs and would have a backup energy of propane gas. So we have set the study, we have set the case studies that represent the industries desired. Now let's see the literature review, let's see the technologies available, and let's see how they behave either economically or environmentally. The first technologies will be seen. It's the first of the technologies, as we see, is heating gas oil. For each technology, we approach by first literature review, afterwards making a data sheet, technical view of the fuel involved, and greenhouse gas emission factors, and afterwards the data and the market, the economic data. In heating gas oil, we already see that it's kind of good technology and it's very known. The interesting about this technology in the perspective of investor is that it has a very considerably low installation and equipment acquisition price. Regarding propane gas or liquefied petroleum gas, the literature review was, for instance, Conceitos Básicos sobre o Propano of NREL, Department of Energy of the United States, in 2010, and Study Measures Impact of Propane Gas by LP Gas, 2011. The lower heating value of propane gas is 46.3 megajoules per kilogram. The volumic mass is 510 kilograms per cubic meter. The efficiency 90 to 95%. Greenhouse gas emission factors are 227.16 kilos of CO2 equivalent per megawatt hour. Greenhouse gas emission factors were taken from APA e NERPA, Inventário Nacional de Emissões por Fontes e Remoções por Semidores de Poluentes Atmosféricos, 2009, and lower heating value was taken from ADEN, Despacho 17.313, 2008. Again, the data for Portuguese market, where we see a particularity that propane gas can use about the similar equipment than heating gas oil with a little change in the burner and other minor changes that can be pursued to allow the work of this kind of fuel. In natural gas was studied an interesting issue is that its natural gas is a little less pollutant than heating gas oil and then propane gas. We can see this because greenhouse gas emission factor in natural gas is 201.96 kilos of CO2 equivalent per megawatt hour. A particularity of natural gas is that it can cost very cheap, and the equipment is again fitted to have natural gas. Natural gas can be and should be considered also as comparison with natural gas condensation boiler, since condensation boiler allows to take advantage of the evaporation heat that is lost of the water. So because the condensation is taken back to the system by a condensation boiler. So the lower heating value can be used, but to calculations we can use mostly higher heating value. The efficiency is, as expected, upper and increased, and the greenhouse gas emission factors are also lower than natural gas. The condensation boiler has the following aspect, and we can see that it's not very expensive, it's not very much expensive than the natural gas boiler. Regarding to the condensation boiler, we talk about the price, but it was important to see that the powers involved were slightly different, which justifies a little different in price. But overall, we can say that condensation boilers are a little less, or a little more, let's say a little more, yeah, a little expensive than the plain natural gas boilers. Regarding electricity water heating for Joule effect, we have here the properties, and the thing we have to call attention is to the greenhouse gas emission factors, that in electricity, as expected, are very high, reaching 375 kilos of CO2 equivalent per megawatt hour. In the Portuguese market, we have here the tariffs given by EDP Serviço Universal. Were chosen 4 cylinders, accomplishing for 40 kilowatts. So it was, since electricity is always working, let's say, it was basically what was needed to fulfill the daily needs of water, hot water. Okay. So in this technology, we have heat pump for water heating. Heat pump for water heating is a surprisingly good performance technology, as you will see. COP, coefficient of performance, between 2.5 and 4, and greenhouse gas emission factors between 93.75 and 150 kilos of CO2 equivalent per megawatt hour. The heat pump technology uses electricity, but it's highly performant, as already seen. The problem with this technology is about the initial price, working capital demanding, let's say, because we have here a cost of 28,539 euros, considering overall costs. Biomass. Now we have already listed all the so-called conventional technologies, which are heating gas oil, propane gas or liquefied petroleum gas, natural gas with boiler or condensation, electricity due effect hot water heating, and also heat pumps. Okay, so now we are moving to renewable energies, or the so-called non-scarce energies, or fossil fuel dependent energies. Renewable energies are studied mainly biomass, which are pellets or compressed wood granulates. And the thing about biomass, we already can see that greenhouse gas emission factors are in fact very low, by 58.50 kilos of CO2 equivalent per megawatt hour, and biomass has high initial costs, the equipment of 13,800 euros, being less expensive yet than as expected, okay, than heat pumps. Solar thermal, the second renewable energy technology. Solar thermal has no emissions if we consider 100% solar coverage, which in reality is very hard to obtain and expensive. So in practice, we suggest, as we did in the retrofit, performance between 60 and 80%, 90% of solar coverage. Solar thermal, being the rest, of course, supplied by alternative form of energy. In this case, we have here the accounted for system. Again, working capital demanding system, because solar thermal technologies and renewables are initially expensive, but what pays off is the overall costs, variable costs, very low. So here is the proposal of solar thermal. Regarding, after having these technologies, it's important to assess their comparative performance, and we did so in this net present cost calculation. The net present cost calculation for each technology is what is plotted, and you can see that electricity and propane gas tend to be very high and expensive technologies to go for, and we can see that the greener technologies like solar thermal, pellets, and even natural gas are more economically feasible technologies. Regarding the calculations made, we used as a criteria for technology benchmark and ranking we used the criteria of net present cost. Solar thermal technology yields the lesser net present cost, closely followed by natural gas and pellets. So these are the technologies to go for. And electricity and propane gas are very expensive technologies that should be, as soon as possible, changed and retrofitted to more cleaner and cheaper technologies. Regarding the environmental feasibility, interestingly, we achieve we achieve common conclusions that the same technologies which are in fact cheaper are also more greener. Solar thermal technology, pellets and heat pumps, natural gas are cleaner technologies, which correspond also to the lesser net present value technologies. So they are the technologies that investors should go for. One important aspect is that solar thermal technology has emissions associated because there wasn't a coverage of 100%. So the 35%, because we use the solar coverage of 65%, the rest of the energy necessities are, in the case of milk industry, supplied by electricity, and in the case of cheese, supplied by propane gas. The methodology for the retrofitting and for the system overall was validated using the software if compatible with o regulamento energético de edifícios, regulamento de características e comportamento térmico dos edifícios, by Solterm in Action. This software is for energy technical, economical and environmental analysis of performance and pre-dimensioning of solar thermal systems. The simulation obtained in this software was similar to the results manually calculated, and this was important because the study was validated. Regarding the results, we can say that retrofitting the Herdade das Pedras no Redondo milk producing industry will yield savings in 6 years of 46%, in 11 years 57%, the variable costs will decrease and emissions will decrease 64%. Regarding Cajarica Chopas, the retrofitting will yield 50% savings in 6 years, 60% savings in 11 years, and the variable costs will decrease by 80%, and the emissions will actually be reduced by 41%. So, the results to be attained versus what we achieved was clearly a completion of the goals initially set, and our objectives, and the objectives are set in the start of the work, were fully accomplished, in that savings were obtained, and that retrofitting either milk industry to solar thermal and cheese industry to solar thermal will yield savings in CO2, in costs, as we see savings in CO2 in water heating, 64% savings for milk, 41% cheese, variable energy costs 69% milk, 41% cheese, return of investment 2 years, and validation with the software we attain similar results. So the technical sizing of the system was validated because Solterm allows to make quasi-stationary simulation analysis, and the solar production and the overall production fits the production we calculated. So we thank you very much, and hopefully you liked this presentation so much as I did like to make it. Thank you.